people see. Actually, oh, we're not going to live stream. That's right, but we'll record. So we're recording now. So live from New York. It's Monday night. No, okay. I should do a skit to open it up, right? And the people are watching it. They see. We'll try that sometime. Make it fun. So the Wednesday before spring break was the day to retake the tests. I have them. I think I had 3 people retake them. And I posted the scores. Everyone did better than they did before. If you want to take it another time, we can work that out. If you didn't retake it then and want to retake it later, no problems. We'll just kind of do mastery. So, and we always take your higher scores. Okay.
So you did post the scores? I didn't check.
I haven't gone to the testing center though, so I just got the ones that took it in class. I think I got a notice you took yours, so I'll go pick that one up, and we'll be all good. So, so again, just keep studying until you understand the material. If the tests don't, we'll do practice tests that are closely related to the material, which hopefully should help. You'll do a test. If it's not as well as you'd like, just try to remember the few things. We'll come back. You'll see what you missed. Come back and you'll retake the test, and hopefully, again, add in a few more points and keep building the success. Okay, so let's switch over to here. Take a look at our syllabus just to kind of get us back to where we're at. So we just went through spring break. We got a little bit off. We didn't start lesson 7. We did the retest, those who wanted to. We have spring break, and so what we're going to do is tonight we'll take a look at lesson 7, unit 7. Wednesday we'll look at unit 8, and then we've got the following week to do practice test reviews over those 4 sections. And remember, 5 mostly is an application, so we'll be applying it into 6, 7, and 8. Okay, we'll take an exam, and then we move to the last part of the class, which will be units 9 through 12. And again, before we take that, we've got a full week review. The final exam is not cumulative. It'll just be over those last parts. So it's 3 or 4 chapters. I guess actually each of these will be 4 chapters. 4 chapters a test. The stuff we take on the next test will not be on the final. 4 chapters and a test. So we're breaking it down a little bit more that way. I'm still not sure if I like the way, it just doesn't feel right to me, because usually we allow you to take the test back and review them, but I don't know, we'll see. I'll reserve my judgment for this at the end of the class and see if doing sort of these mastery things let you take a look at what you do and go, and you'll let me know maybe by email, because after the final exam, we may not see each other for a while, but if you maybe after that final one, if you can, in fact, I'll leave the course open and maybe give a little bit of extra credit if you can give me a little bit of your thoughts on how the exams worked for you. If you've taken one where it was a comprehensive final, and do you like it, have it broken down, or would it have been better to do smaller tests with a comprehensive final? And I'll send out a message so you'll have that opportunity after the test just to give me your feedback. Because it's not what I like, it's what works for you guys. And it's, like I said, I'm not really liking it, but I got thinking, maybe I don't want to influence you. If you're liking it, if it's working well for you, then I'll make it work for me. If it's not working for you, then we'll find some other way to do it, because that's really what's got to happen. Okay, make sense? So there's our syllabus. We'll just do our best to hang on and keep going. Or not. Disappear. That's better. We'll just disappear from. Okay, so there we go. That's what we want to do today. So I'm just going to go through, this is the workbook. Let me get back to the beginning. Skip over these. So these are the main things we need to talk about tonight is So what is the difference between a relation and a function? And then what you'll see is we won't actually be working with relation. Actually, a function is a type of relation, so I guess we work with them. But the only thing we're really going to pay attention to for the rest of this class are things called functions. And just to let you know, we've already been working with them. We're just introducing some new terminology tonight. So we'll talk about function notation. I think we've maybe used a little bit of it, but it's just a way of writing things we've already been doing, x's and y's and such. We'll talk about domain and range. Again, we've actually already been using the concepts. We just give some formal definitions. And simply the domain is what are the x values, and the range are what are the y values. Okay, so we'll get into that. Practical domain and range just means we've got a story problem and how does it fit. So we'll take a little bit of look at that. And then 7.5 is applications of everything. Okay, so not too much math directly in here. Before we get going though, how about a word of the day? Or we should do like advice of the day or something, but that might be more than one word, right? Yes?
See, I've been singing this one for my laugh. Abracadabra.
Oh.
Spell it.
No, let me...
Too difficult.
I was watching a show last night, and they had these kids on it, and when they had to spell it backwards. I go, heck, I can't even spell those words forward. How could they spell them backwards? Did anyone watch that? There's like three little kids on a team, 3 kids against 3 tens. I just
Were these
flip
kids
it.
gifted or something?
Yeah, they were supposed to be like geniuses, and they were much. I was going, man. They memorized a set of cards that like had 27 cards, and the 3 of them they had to memorize every third. It was kind of a cool show. I was going, man, those kids are, yeah. Anyway, interesting. Abracadabra. So let me try, and we'll see. And this will become the official spelling of abracadabra. Abracadabra. Does that look about right? There's probably a couple extra B's in there that are supposed to be. Is that
Looks all right to me.
looks all right? Abracadabra. At least it's phonetic, right? And again, it's a good thing it's going to be multiple choice, right? You just got to choose it. So, abracadabra. Yeah. I wonder, does anyone know what it actually means? Because, abracadabra, you do it in music, but magic. Does anyone know what it actually means? What language it's from? There's some extra credit. Find it out, and we'll give you a few extra points. Google it right now, yeah. Because it might mean something like, I don't know. It looks about right. So we'll record this as the first slide. It's MAT091. We'll go with page 01 tonight. So I'll save it. Oops, what happened? Did it really save? Hopefully. What happened? I don't know. Oh, there it is. Okay. Let's save it, and then we'll just keep moving forward. Get a new page. Okay? So, yes, shrink this down. I'll give you my...
He spells it right.
Was spelled right? Wow. That's amazing. I'm surprised by that. I thought for sure it would have had...
So what's the origin?
Roman.
It's Roman, really?
It's Latin.
Latin, huh?
But the Romans used it, right? Came from a disease, and they said that word was supposed to help them heal from malaria or something like that.
Makes lethal diseases go away.
Yeah.
My goodness. I would have never thought that. Let's see. I think I can delete that. Let me...
Oh, like disappear. That's where they use it in magic.
Okay. So we'll just forget about this. Let's see. I think that's worth writing down. Okay. So what does it mean? It means make a disease.
D-I-S.
D-I,
Dis.
disease.
Yeah, E-A-S-E.
Yeah. Disease, disappear. It's Latin. Interesting. Wow. See, you learn something new every day, even if it's not math. Okay? Cool. Clear that off. Let's see, how can I get rid of that thing? Oh, I know. Go here. Click that. I'm going to move that to the trash. We don't need it. Okay. So, let's see. What is a function? Well, before we'll just orally talk about a relation. What is a relation? What is a relationship?
Well, function is a relationship. It's just a specific type.
Yes. So what is a relationship, though?
It's
What-
any set of ordered pairs.
Okay. How about in real life? Let's get out of the math classroom. What is a relationship?
Challenging.
With the emotions set beside it. What is a relationship? What do you need for a relationship?
Two people.
Two people. Okay. Can you have a relationship with your pet?
Yes.
So a person, an animal. Could you have a relationship with an object?
Yes.
Pet rock. We used to have pet rocks back in. Anyone had a pet rock back in, what was that, the 70s or 80s? 70s. That's what I thought. Yeah, I remember. Pet rocks. Yeah, so you had to pay all this money for this little thing and add papers and stuff and names. And so, yeah, you could have but basically you need two objects and there's something connecting them together. Okay, so we'll just do sort of a sub of relation. Just put two things that are connected somehow, some way. Could be the relationship between a mother and her children, a father and his children, a children and their parents. So there's various types of relationships. There's relationships we get into. There's students and their teacher and their students. So there's various ways to define a relationship. You can talk about objects. A car is connected to its parking space. Sometimes you have numbers parking spaces in your complex, and you better park your car with the right license plate in the right spot or it might get towed, right? So there's those kind of things. It's sort of a one-to-one, that there is this relationship between this object and this other object, and something connects it. Okay, so that's just a relationship. A function is the same thing. A function is a relationship, so it involves two different things. But a function has an additional rule. So when we talk about a relation, oftentimes we'll talk about one of these things is an input, and the other thing is the output. Okay. And for a relation, there's just something that connects the two. An input can have actually multiple outputs, and an output could have multiple inputs. Like a mother could have more than one child. Can children have more than one mother? It depends on how you define it. Maybe not more than one biological mother, but maybe you can adopt, you have mother-in-law, right? Stepmothers. So a relation doesn't have this special rule, but what a function does, just draw down here, is it has to obey this rule. each input must have how many outputs?
Exactly one.
Exactly one. This is the rule of the day. Basically, everything we're going to do is we're going to apply this rule to some examples to get a feel for how this works. Does this rule say anything about the output? Does it put any restriction on an output? It doesn't. It's just a result. It's basically a rule for the input. So each input must have exactly one output. So first of all, it says, I might be a little different than what the book says, but the way they apply this, each input it needs to have an output, or else it's not a function, and it can only have one output. Okay? So we'll take a picture of that, and then we'll start. But noticing things are paired up. So when we've talked, I think you did mention about ordered pairs. We're going to look at that from the perspective of it being a function. And again, we'll decide when it's a function and when it's not a function. Guess what we get to do if it's not a function? We get to ignore it, because we're only going to work with functions. So basically, our first part is just to say, is it a function or not? If it's not a function, we just say, we ain't going to deal with it. If it is a function, then we can work with it. That's mostly what this chapter is about. Okay, and then we're going to learn ways of dealing with things that are functions. Okay, but this rule here is what we're going to be following. That's our deciding factor of whether something's a function or not. Let's see, where did I put that? There it is.
Three.
I didn't save that second one, so
Oh,
yeah. No, it's got 3 up there, but something I didn't save. I didn't save the definition of abracadabra, so you'll just have to watch the video if you want to see that. Okay, so now let's pull up. Where's the other one? Where did they go? Shrink it down. Should be right here. Oh, there it is. Okay. So now we're going to look at a few things. So again, here's a relation just really is any set of ordered pairs, talking about math. And a function, every input is paired with exactly one output. So kind of similar to what I just wrote up there. Okay. So then we'll look at these examples. So for this first example, does each one of these inputs only have one output?
yes,
Sure?
yes.
Really?
Because the inputs are different than the outputs, so there's
Very
only
good.
one output to the
Yeah.
input.
So the rule is the input can only have one. So 2 has 5, that's only one input. 3 has 5, it's only one input. 4 has 5, that's only one input. So yes, this is a yes. So the outputs can be repeated. So I say this is like a double standard. So the input has to be monogamous, it can only have one, but the output doesn't need to be. Society has certain levels of double standards in various relationships, right? So let me ask you this, so we talked about, let's get away from the romantic side of things. A mother and her children, is that a function? If the mother is the input, how many outputs could she have? If it were a function, she could only have one, but
they're all different outputs.
yes. We had 5 children in my family, so my mother had 5 different outputs. That's not a function. But if we look at it from the relation, from the child to the parent, how many biological mothers can you have? Just one. So each child would have one. If the child was the input and the mother's the output, then that's a function, because each child can only have one biological mother. But a biological mother can have more than one child. So that's not a function. So what you're going to see is that there's some things that are function in one direction, depending upon how you define the input and the output. But if you switch that input-output, it's no longer a function. Okay?
That's a really good analogy.
Good. It's one of my better ones, yeah. Sometimes I talk about romantic relationships and we get all kinds of things. But, yeah, because we know it's supposed to be a one-to-one relationship, right? I love you, you love me, and that's it. And then, unfortunately, those things aren't functions too many times. Hopefully they are. Okay, how about this one? Is this violating any of the rules? And if so, where does it do it?
3.
That has one, that has one. But 3 goes to 7, and again, it mentions it again, so if I draw it this way, it's really got 2 separate outputs. So it's been repeated, and it's got 2 different outputs, so it's cheating. Nope, that's not a function. Okay, so we don't deal with stuff like that. Last one, 2, 1, 4, 3. If the input is not repeated, is it possible for it to not be a function?
Say that again.
If there's not a repeat of the input, is it possible for it not to be a function? No, it has to be a function. As long as there's an out, because each one of these is going to have an input.
Exactly one.
Exactly one. So this one, yes. So I'm just going to clear off the screen. That's right. Let's go up a little bit more.
I'm curious in the workbook why they grouped them together on A, B, C, and D, and then you had to answer yes or no. And because there were, I think it was B, there were 2 within B that were 2 2s that had outputs. So there were 2 inputs that were the same, 2 outputs that were different, but that was considered not a function.
Very good. So when we read it this way, ordered pairs, the first one is the input, second one's the output. So we look at this input, input, input. So these are all different, right? So this is going to be a function. Let's get to this one. Here's an input, here's an input, but do they have the same output? So I think of it like every question has to have only one answer. And so if the input is the question, I ask what is 2, and one time you give me the answer -3, another time you give me the answer -5. You gave me 2 different answers for the same question. That is not a function.
Okay, that makes sense.
Okay, so that's the way to think is the input is the question, the output's the answer. Each input has to have the same answer. Okay, can't ask mom, she says no. You ask dad, he says yes. In my house, it was usually the other way around, but okay. So it's you always got to get the same answer to the same question. Okay.
We went a little fast. Why? Can we do this? Why is that yes?
This is the top one.
Yeah.
Because each of the inputs is only listed once,
Okay.
and each of them has an output, so there's no possibility of having a repeat. Okay.
Okay.
If I had another ordered pair out here and I used 5 again, now it's possible that this could not be a function. If it were a function, what would this 5 have to get paired with?
0.
The 0. So if I go 5, 0 down, this remains a function. But if I list a point and I say 5 now gets matched with something else, 13, whatever, I just made this not a function. So I can make it a function by erasing that one.
So it's the same thing like it was in the chart there, just where it looked at. Just
Yes.
differently.
If you wanted to, you could put them into charts, inputs and outputs side by side. It's just another way of looking. And that's what you're going to see is this is the same concept, but we're going to look at it in different ways. One as a table, one as a set of ordered pairs. We're going to see what it looks like when we put it on a graph. And I don't know, we might look at some other things. I try not to get too much into the lesson and be just as surprised as you are when something comes up. Figure it out as we go, right? Okay. And again, some of these are in the, they're media examples, but I like to do them too because maybe they explain them differently, and maybe if you watch this and you don't have to watch those, that's fine. I give you just multiple chances. And maybe I don't do a good job, so you watch the video and like it better, that's okay too, just as long as, again, you're satisfied you get what you need. How about C? Let's do this quickly. There's a -5, a 2, a -3, and a 0. Do we even need to look at what the outputs are? No. It's guaranteed it's going to be a function. Okay? So yes. Again, because there is no repeated input. Okay? So all the x's are different, so there's no chance for it to be repeated. So that's kind of the. But this is one. Look at this 3 and this 3. Okay, I see a repeated input. Now what do I check? Do they have the same output? Oops, nope, one's been messing around. So that's not a function right away. I don't have to even check these. I'm looking for a same input with different outputs. That's what's going to be a non-function. Okay, how about this? There's only one point. Sure, it's fine. There's only one input. It does have an output, so yeah, that's a function. All right. Oops. Okay. And you could actually, they give you this area if you wanted to plot the points on there, you would see what happens. Anything that's not a function, you basically get 1 point above the other. Okay. So I'm going to just kind of do it with this.
I thought that was a good example on the graphs because it shows why you couldn't have two outputs for the same input.
Exactly. Good. So what I'll do is I'll just kind of drop down here and let's start with this last example. Does this input, how many inputs or outputs does this one have? There's its output. This input, there's its output. This one, there it is. This one, there it is. This one, there it is. There's that out. Does any of these inputs have more than one output? No. If it did, what would happen? You'd have 2 points like here and here. So this is what they call the vertical line test. If a vertical line crosses the function or the relation in 2 places, that input has more than one output. Does that make sense? So this one as it is, yes, it's a function. I just erase this this added point. Okay, so I'll get rid of that. So let's come back here. How about this circle? Is this a function? No. Let's test this input. If I draw a vertical line, I see that there are 2 places that the vertical line crosses. That input has 2 outputs. Okay. And you can see there's more than one place that happens. So this is not a function. Now, how about this one? Actually, I've got lines I can draw, so let's do this. Let's draw the vertical line straight down. It's crossed in more than one place. And again, any vertical line that crosses in more than one place, that input has more than one output, it's not a function. So aren't you glad we don't have to do graphs like this? Or circles. We don't study circles or those. But how about something like this? Yeah, it does. You can draw multiple ones They should be straight up and down, but you'll see they'll only cross in one place. So this one, yes, it's a function. So far, so good. So each input has exactly one output. Exactly one, no more, no less. Then we got a function. Okay, that's really all the concept. You'll get questions like this, and you'll be able to go. Okay, so another thing they tuck in here is the behavior of graphs. How do we know when a graph is increasing? Low to high when we're reading it from left to right. Good. So increasing is always defined from left to right, going up. Now be careful, because this is the problem I had. I could read it backwards, and I could see this is going down if I go right to left. But in math, you just have to fix yourself for always reading graphs from left to right. Okay. So then what does it mean to decrease?
You're going the opposite downhill from left to right.
It doesn't have to be straight, but yes, so we're going down.
That's the same thing, though. You could misinterpret that if you weren't.
Exactly. If I was going the opposite direction, I could say, well, I got to climb up the hill. But again, it's always based on reading from left to right. So if we read a graph from left to right, what is always increasing? Which of the values always increases on a graph when we go left to right? X is always going to be increasing. So when we talking about increasing, decreasing, we're making it in reference to the y value. So what's going up? What is it that's increasing? It's the y that's increasing. X is always going to be increasing because we're left to right, it increases. What's decreasing here? The decreasing part, the y value. Change colors, why not? The y value is what decreases. And then when we've got something that's constant, straight line, horizontal, straight across, the y is staying the same. Okay. X is still increasing because we're reading it left to right. X is always going to increase. The y stays constant, doesn't change. Okay. And again, we'll bring this, and this takes you all the way. If you're going to, some of you may go on to the science-based stuff. You go into calculus. This is a big question with calculus, because if it's increasing, the rate's increasing, and that's one sort of decision. If you're running a business, costs are going up. That's one decision you make. If profits are going up, then that's good. Maybe you want more of your product, but you need to know what's the trend. Is it going up, or is it coming down, or is it staying constant? These are the things we use the math for. Okay. And again, with graphs, it's nice because you can kind of see those. Okay. Let's see. So it's just kind of a mix of a lot of different concepts of dealing with graphs, dealing with functions. We'll throw one more thing in here. So talking about inputs and outputs, I would have probably switched the order, but there's two other words we put with these. Independent variable is what the input is. So you'll see this word used mostly in statistics. Any of you think you'll be taking a statistics class? If you're going to do any kind of research or be like educators, usually we have to take a statistics class because we're consumers of statistics. And just we do teach one here. It's MAT091 in the math department. However, they do a really good job over the psychology department as well. And it's Psych 230, so it's kind of a higher level class. Well, no, I guess 200 level. But at some schools it'll actually transfer as a 300 level class. But what's really nice is if you take it together with Psych 290, which is as a research methods class, that counts as a science. So if you're looking for a good science to take, you could take that and the statistics class. They go together pretty nicely. You could take it both the same semester. It's also in the psychology, you only need Math 90. After this class, you'll have the prereq to take that statistics class. The one in the math department, you need one more math class to do it. It's a little bit more mathy, more formulas. In the psychology class, they use more technology, and it's more understanding how it's applied. So I just give you both those options because a lot of, if you go to get a bachelor's degree, a lot of times they're looking for a statistics class in a number of programs. And again, we do have two different classes, actually three different. There's one in the business department, but they have a few other requirements for it. So the one I kind of recommend is the psychology class, and I know the professor who teaches it, and it's very, he gives you a page of notes for each of the tests, so it's, they just do a good job of actually helping you understand what statistics are about.
So the psychology class is Psych 230 statistics, and then what's the other course that goes with it?
290, Psych 290. They're great ones if you take them together because in the 290 you use the statistics stuff, and so if you're taking them together, it's really beneficial. And again, one of them counts for a science. The 290 is a 4-credit class that counts as one of your sciences. And it also helps you even if you're not going into psychology, it's really a good way to understand research, whether you're going to do research yourself or whether you're just kind of a consumer of research. Those are really good ones. The 141 I teach, we have a short segment. We have 2 units worth of statistics that get you started. But that's just enough to get you started. These other classes will take you the rest of the way, give you an understanding. And again, we're all consuming statistics. There's all these reports that come out, and they'll use statistics in it. And if you don't know anything about it, it can become easy to be pulled one way or the other, and without the statistics maybe being used correctly. Okay, but independent variable, you'll see that in statistics. And dependent variable is the output, because whatever the input I give you, the output's going to depend on that. Okay, so the input in math, we do it. We plug in a number, do some math on it, and then your output depends upon whatever number you put in. Okay. And what it starts getting here is the theme throughout the day. The input for us is going to be the x variable. The output is going to be the y variable. And you're going to see, when I see input, I'm always going to be thinking, you'll see the word in for input. Dependent and output, they have different words. So I will typically focus on the input as being in and the output as something about it is out. Okay, so we'll see that when we get to the function notation. Okay. Few more examples. I don't think we'll go through those, but that was a definition I wanted to take a look at, which we did, and then we'll just keep moving forward. Okay. Now we're to the next section. Okay, and this is where we start working with function notation. So it's just think of this as tonight's lesson is like more of a language lesson than a math lesson, or the language of math. So this is, again, nothing really anything new to you, just a different way of writing it. So what we do with function notation, we now have a new way of writing things. We use this little f in parentheses, input and output. Now usually in math, when we put parentheses around something, what do we mean when we put parentheses around something? Do first, multiply, connected. So yeah, usually we might write something like 3, and we put the 2 in here, and it sort of implies, well, you can't do anything with a 2, but doesn't this sort of imply 3 times 2? Okay, it does, and that's what it's supposed to. So if you see that as 3 times 2, you're good, and you'd write 6. But the thing is, we're going to start writing this notation now. Does this notation mean f times x? Question mark. And the answer to that is it doesn't, but your brain is thinking it does. Whether you say, no, it's not, it probably is. In the background, you might not in the back of your brain, it's saying that looks a heck of a lot like multiplication. And so when you get to working these problems, you're going to want to maybe divide out or times or something. That's an extra step we don't want to do because this does not mean times. So that's one of the, but I want to address it this way because I want you to realize you're going to have to fight that thinking of your mind because your mind's going to want to think of this as multiplication because we drilled it into you that parentheses mean multiplication. Yes. What we use it for here is this is supposed to mean f of x. So x, whatever x value is getting plugged into some function that is named f. So f is not a variable, it is a name for something. X is a variable, it's getting plugged in, and then gives an output of y. Okay. So here's another word for the used for the input. The input is always in the parentheses. The output doesn't have parentheses, it's out of the parentheses, okay? So I'm kind of jumping around a little bit, but I want to just jump to it. So this is some function v of 36, not v times 36. So v of 36, so equals 17.4. So what does the 36 represent? Input or output? Input. Why? Because it is...
First. Because it's first.
Not really, because I could switch the order and it would still be input. What makes it in is not so much at it first, although usually we will have it first. What makes 36 the input? It's in the parentheses. Okay, so just emphasize those things because that's, yeah, it's input. And here I'll yell at you. It's in all capital letters, both of them. It's in the parentheses. Parentheses. Okay. Good. And so when we come up here, we have to look what M is here. So M is the input. What does it represent? Months. So this is a key part. Is you just have to. You'll have two variables. You'll have two units to go, a unit to go with each variable. And if you can keep track of input and output, you're right on track. You'll just be fine. Okay. So this is saying 36 months, something happens. Well, what does the other variable be? Well, we could call V, maybe the other variable, the output. It's the value of an investment in thousands of dollars. Okay, so we got two things that can vary. So what is the 17.4 telling us?
Interest.
It's the output. And what is the output?
Thousands.
The value in thousands of dollars. Not just the interest, but the total value. So in 36, we could just say, in 36 months, our investment is worth 17.4. Now this you could take it times 1,000 because that's actually going to be 17,400 in thousands dollars. So you could write that out. But notice how if I give you function notation, that little v parentheses 36 equals 17.4 is actually saying a lot, but you have to know what the variables mean. You have to know what the input is. You have to know what the output is. And, you know, this little thing right here is saying exactly the same thing that this whole sentence here is saying. Now, did we do any math on that? We didn't do any calculation, but we were able to interpret this using the language of math. Because who else is going to know what v of 36 equals 17.4 means, right? Okay, I'm going to just kind of jump ahead. Is there another way we could write this? So this is function notation. Is there another way we could have written input and output?
Parentheses,
Good.
ordered pair.
Like an ordered pair, right? 36, comma, 17.4. So we've already been using this sort of to a certain extent. We just get a new way to write it. So we can write it this way, or we could write it the way they had it, and it means exactly the same thing. Input equals the output. Okay. I can interpret them both the same way. Input comes first. And right, an ordered pair input always does come first, so it's kind of nice when they write it this way. But an equal sign, they could actually switch it around. They could have given it to us as 17.4 equals V of 36. It's kind of a, and it really does, 36 is still the input, 17.4 is still the output.
Is it always going to have like that B in front of the input or the whatever letter it is?
Right. The letter could change, and oftentimes they use the letter to name the function.
But it's
of
always going to
something.
be the input, which one next to the variable?
Yes. The input will always have parentheses around it. So there'll be a letter and then a input. Could be H, could be G, could be F. So that's the part that changes, but the thing inside the parentheses is always the input. Can I say that again? The thing inside the input, inside the parentheses is the input. Just N. Yeah, N's always go together. Say it more, yeah. Say it till you get tired of it, and then you'll know it. Okay. Good. Oops. There. Let's get a new one. Okay, so we're down to 7.2. So how do we use function notation? Okay, so this is just an example. And again, it's in the video, so I'll let you do it. But they give you an example. 2 comma 3 could be written as f of 2 equals 3. Negative 4, 6. So where does the negative 4 go? In
The parentheses.
in the parentheses, because it's the input. Outside of the parentheses, the output. So the 6. And again, we could go back and forth. So 5, negative 1, 5, negative 1. Okay, so just kind of see, it's really what we started doing in lesson 5 using ordered pairs. It's just now giving us a different way to write it. We're like learning a little French or something, learning a different language. And that's what math, a lot of times in math, what makes it difficult is they'll have 2 or 3 different ways to write exactly the same thing. If you go into calculus, there's actually 2 different ways. It was developed with 2 different ways to kind of write the notation of calculus. And the problem is one was German, one was French. No, Isaac Newton, he was British. Anyway, they came up with different ways of writing it, but when you learn it, they use them both at the same time, and it's really difficult.
Do they
But
use them interchangeably?
They do. So you find the one, what I found is that as you go through that, you find the one that you prefer the most, and you just learn how to translate it into that. When I get to calculus, that's what I did. I found out the one that worked for me. I would rewrite a question that was in the other form in the form I was familiar with. I would do my work, and then I could translate it back to the other form. But I couldn't work with one of the forms that, I think it was the German form. It didn't make sense to me. The British form made sense to me, so I used that one. But I could translate either the beginning or the end back and forth. Okay. And you could find that you may do this with the function notation. So we'll show you when we get a little bit more down the road. Let's see. Okay. Examples. So let's just take a look at a couple more examples that are a little bit different. So if we've got a table below, we've got one with the table. Let's see, where are we? With the table of values and the one with the graph. And then I think we've got domain and range after this. So when we are asked B of 12, how do we find what the output is when we're given a table? Input is up on top, so we go to find the 12. There it is. How do we find our answer?
Below.
Right below it, 50. Okay. So it's just looking up. Does it feel like we're doing math? We're not calculating, but this is math, looking up in tables. Okay. Now, how is this one different? Where's the 18? Is 18 input or output? How do we know? It's not in parentheses. It's out of the parentheses, so it's output. So how do I look up when I'm given an output? How do I find the input? I go to the bottom where the 18 occurs down here, and then I look up. So it's just a reverse order. These are the two things you're going to be doing the rest of the class. I'll give you an input, you find the output. I give you an output, you find the input. That's all we can do. That's all math is. There's not a third thing in there, which is cool because juggling is with 3 balls is hard. Anyone can do that? I can't. I've tried. I can do 2 balls or at least make it look like them, you just switch them. But so that's all you got to do is 2 of them. And so 18 is going to be 31. Okay? T is 31 when the output's 18. Notice there's another 18, but this is when the input's 18, the output's 39. So it's a completely different question. So far, so good? Awesome. So on the graph, if I give you an input, right, G of 2, how do I know 2 is the input? It's in the parentheses. So I'm looking here. Here's where the X is 2. How do I find the output? You go up or down if you need to, but in this case, yeah, go up until you hit the graph. And then what do we read? We read the Y value, which is 1, 2, 3. Okay? So the output is 3. That's a Y value, X and Y. How is this one different? Oops, before I go there, let me ordered pair 2, 3, right? Because that's the point on the line. What is this question asking? Y is 2. What is 3? So again, we go up to where Y is 2. It's here. Go over to the line till we hit the graph. And then what do we look for? We look for the input, which is 4. And again, we could write that as an ordered pair, 4, 2. Okay? So far, that's all this section is looking up things in the right order. But this really gives you a tool to do some real powerful things. Because if you can get a graph of something, you can find your data values. You can find your relationship. You can actually do math. Those of you who go on to the college algebra, the 121, we use the graphing calculators to actually do mathematics graphically. We graph them, and where 2 things intersect, that's where they're equal. That's how we solve a lot of things without algebra, with just getting a tool to draw the graphs. And there's a lot of advanced stuff that used to be like graduate level math that you can do with a graphing calculator, and you can visually see it and understand it much better than in the old days when we used to do all this manipulation and try to figure out what was going on. So far, so good? Questions? Concerns?
Are there 2 more problems?
Probably. Yeah. Let's do this G of 0 because this is actually one of the harder ones to do. It's like one that's usually on a test. I think the other one might be okay. So when I got G of 0, where do I look? Where do I start from? The center, so 0, 0. Now the hard part is if I'm here, do I go up or do I go left or right? Since I'm looking for the output, I have to go up. So when I look for an output, I'm either up or down. So I go up and I find it here. What's my value? 4. Okay, ordered pair 0, 4. And this one, 1 is what?
Why?
It's a Y, it's an output. So I come here and then I go to the right. Not a big deal. And and then 6 is my input. So an input of 6 gives an output of 1. I just need to, again, I'm doing it one or the other. The only problem I get is when I mix them up. And that's not that hard to do, believe me.
So where was the 6? I mean, I know.
So here's the 1. I
Right.
go over till I hit the graph, and the 6 is down there. So I go over. So there's my answer. Okay. Awesome. And I got a couple questions. I do different graphs with this, but that's all you got to be able to do is look them up on a graph. But
That's
I'll tell you
almost-
right now.
It's almost like the converse of what we learned in lesson 5.
Right. It's taking what we learned. What if I did this? So where do I start? This is saying y is 0, so I go there. Notice it's the same. I'm at the same place as when this was, but which way do I look?
Across.
I'm looking across because I'm looking for the input. So I have to know this time that for this question, I go from here and I go to the place that crosses here, which is an x value of 8. Okay, but I give you these two questions, and again, this is one of those. It's like on it used to be on the final exam. Now it won't be on the final exam, but it might be one like this. And these two questions, it's so easy to get them backwards. But you have to say this. I'm looking for. This is the output. And here I'm looking for input, so I have to go left or right, not up or down with that one. Okay, but I find this is the most challenging of the questions because both of them are starting at the same place. You really have to know up or down. All these other ones, it's G of 2. If you start here, you kind of usually it's a lot easier to know. You just got to go up. But when you're at here, now you got to really pay attention whether you're going up, down, left, or right. Okay, so those are typically when I'm looking for x or y intercepts. Is really all it's doing. That takes you back to 6. It's challenging because you have to slow down. You want to go too fast, and then that's when the mistakes creep in. At least for me. I don't know about anyone else find that when they go faster that you're going to make more mistakes. But you feel like if you're supposed to go faster, that means you're smarter, right? I don't think so. Slow and easy and getting them accurate. Like typing, you could type. I used to really type fast when they had typewriters. They don't have typewriters anymore, do they? But it's not just your speed; it's your accuracy, right? You can put a lot of letters on a page real fast. I used to do that. I'm fast. Didn't write any words, right? So you got to be both fast and accurate. And it's better to be accurate than it is to be fast. So you can be both great, but try for accuracy first. Is my suggestion. Okay. And again, more of these type of things. Ordered pairs, function notation back to ordered pairs. And just give it a try. There's a table of values. Again, some lookups, either input, find the output, find the input. Practice with it and just get it, set in your mind which is which. Because there's only two things, but if you're like me, there's a left hand and a right hand. But how many of you, when you're told to go left, you actually go right? I'm one of those people. You have to, or you tell me to go left and I go right. You tell me to go right, I go left. I don't know what it is, but it's an easy thing to mix up. That's the same thing here. Again, if you don't have issues, you're probably just fine. That's great. But if you do have issues, at least recognize it. Okay? Okay, so we're almost to the last part of 7. Let's see, how long? We go till like 7:15. We'll probably be done in like 15, 20 minutes anyway. Give you time to review a little bit. These ones, at this particular time, we'll see how heavily we have to hit this, but in this class, domain and range are not as important of issues as it will be in the next classes. But let me just kind of try to highlight what it is, and we'll move on to the more challenging questions as we go through this. Let's go with blue. So domain, what's the domain? It's all the possible input values, all the x values. Okay. What is the range? The range is the list of all possible output values, or in this case, all y values. Now, it's somewhat unfortunate, I think. The word range, what does the word range mean? Like I said, I got a range of values.
Average.
Span is maybe
Yeah.
more, yeah, so
More
that,
than one.
more than one, but it's sort of the span from lowest to, when we use the word range, it's from lowest to highest. It's the span of what I have. So the range is a good word for thinking of what, when I talk about range, it's the span of the y values. The domain is actually a range of the x values, but we can't use range. We could call it range 1 and range 2. But that's, I think, where the confusion comes in, is both the domain and range are ranges of values. They're spans of values. But when I say domain, I'm saying the span. I think I never used that word before. That's a good one. Span. That should be our word of the day. I think. So the domain is the span of the x values. The range is the span of the y values. So I've been teaching this for 20 years, and that's the first time anyone's ever used that word, and it's just like the perfect word. I think I'm going to write that down, and then I'm ready to die. I think so. Okay, it's kind of, yeah, I don't know. It's cool. I don't know. Might not be that cool to you, but you teach something for 20 years, and then finally you go, dang, why did I use that 20 years ago? Bet you I would have taught it a lot better. I don't know. So domain is a span of the x's, range is a span of the y. So we'll use it again. Just write it all over. Not to be confused with spam, which is something different, but span. Okay. So let's just look at an example. Again, there is a video of this, but what are the input values for this function here?
-2 to 6.
Good. It's actually not -2 to 6, though, is it?
No.
It's because it doesn't include the stuff it's only including these particular values. And so when we list the domain, we actually just list these values. And we separate them by commas. Okay. So if we got specific values, we do that. Output values. Again. 3, we got -7, we got 11, we got 3, we got 8. What did you notice about 3? Got listed twice. So when we go to list the range, we only have to list it once. And I'm not going to get real critical. I don't know if the MAT091 does. A lot of times they like the range listed in order. So I put -7, 3. I'd only have to list it once. Then I'd go 8 and 11. Okay. So it's all the y values, but you don't have to repeat. If you got 2 y values that are the same, you only have to list them once. Now that won't happen with the domain, because if I had 2 different domain values or 2 same domain values, it probably is not going to be a function, and we're not going to work with it. Does that so far kind of make sense?
Can you say that one more time?
If I had 2 domain values that were the same, it's very likely that it would not be a function, right? Because I give you 3 and 3 as your inputs. They would have, that's what's going to blow up the output. So domains are usually, when you're listing them, you're just going to, and usually these table of values, they list the domain is listed in order because that's our independent. It's that the range that can sometimes be all over the board. Okay. Here's it as ordered pairs. So what is my input values? The x's. Excellent. So we just list them down. 2, 5, 8, 11. So I could just list them as values. When I go and list them in these, what they call curly braces, I put commas. Okay. Do the same thing with the output values. -4, 7, 0, and 23. They're all different. I could just sort of write them down here. And again, when I go to write them in this sort of formal range thing, I try to get them in order if I can. Again, it's not a big deal, but it should be -4, 0, then the 7, and then the 23. domain and range. What are the x values? What are the y values? Let's list them all. Okay. So that's when we have what we call discrete data. We've only got a certain number of points. We're then going to get into talking about what we do when we have graphs and stuff. But that's basically it. Questions, comments?
Why do they have you write it 2 times, 2 different ways?
Sort of, this is our scratch work, so they just want the values, and up here, it allowed us to see that we had the 3 listed twice, and so we're only going to use it once. And then when we put it in the range, we order it from smallest to largest.
But that's only in the output, that's only in the y
Right.
values. If
Yeah.
it was 2 times in the x,
Yeah.
you wouldn't or you would write it twice?
Oh, like I said, this is scratch work. Once you know what you're doing, you don't have to write it. I would just go for the formal. And the domain, just go ahead and start with that. The range, again, you might also just look at the range and be able to write it once. It only needs to be written once, but I don't really.
I'm asking specifically if they had the input value written 2 times the same
Oh.
number.
Function.
Yeah.
Oh, if it was written twice,
Mhm.
as long as it had the same output, it would still be a function, and I'd only have to list it once.
Okay.
So we only have to list them once. Okay. Clear the screen. And we'll go take a look at the ones that are a little bit more challenging, which are graphs. Let's see. Why this one? Okay, so we'll stop at this one, and then there's a couple below here, and we'll talk about what happens. Okay. So first of all, let's go ahead and draw some lines. So when we're talking the domain, we're talking x or y values. X goes what? Left to right or up or down?
To
Left
right.
to right. So when I want the domain, it's basically I'm coming along from the left. I first hit the graph or hit a point on the graph. I'm just going to draw a box around that. So this is the start of my domain, right? -5. Where's the end of the domain? Across here. Here's the last point. So this is the end of my domain. So I'll draw a box or a line straight down. So that's my domain. How would I write that? The domain, x is in the middle. Where does it start? -4 is less than or equal to x, which is less than or equal to what value? 6, because I'm looking at x values. Okay? When I want the range, what I want to do is I want to come back up here. I'm going to make this a blue one. When I'm looking for range, that's the y value. So do I look left to right? No, I look from bottom to top, up or down. So I come from the bottom, and that's where I first hit I see this is the first point, the first y value, so I'm going to draw a line there. So that's the bottom, and then I go all the way to the top, and that's right here. Would you agree with that? It's the highest y value. So we draw sort of a... Okay. And so my range, -1, I'm looking at the y value, right? So sometimes if you don't do this, you look at the point and you get mixed up and you put the x value when you needed the y value. It's -1 is the y value. Notice less than or equal to the function value, the output value, and then it goes all the way up to 5, 6, 7, 8. Looks like 8. Okay. So that's one way of writing domain and range. This is called inequality notation.
Could you do that, the range one more time, please?
Sure. We go from the bottom all the way to the top. And so with the bottom, we're reading the y value is -1.
Okay.
And at the top, the y value, again, always looking at y values with the range, is 8. 5, 6, 7, 8. Okay, so you might try this, it's nice having a ruler with these ones. Just go ahead and draw, and of course, maybe not on your computer screen, but that's once you get the concept down, then you can get maybe away from drawing the lines, but it's very helpful. Sometimes if I'm on the computer screen, I'll have a ruler or even a pencil, and I'll go like this, left to right, bottom to top. Okay. So this is inequality notation. There's another way to write this. The domain can also be written as going from -4 to 6. And then since we have these less than or equal to, since it's included, we use this bracket. We use a bracket. You're going to see there's some places where we will use a parentheses. But the reason we do that is because these have closed points at the end. And we'll talk in the next few examples, they have some that have open points, and you'll kind of see the difference there. How would we write the range? -1 to 8. And again, this one, since the endpoints are included, we use brackets on both sides. So this is called interval notation.
It's kind of like the other notation in the previous.
Yeah. And so just think of it, it's a different language. Somebody else came up with a different way to write it, and you could choose which either. They both say the same thing. Both are saying that the domain goes from -4 to 6, -4 to 6. They just say it in a different symbols. The range goes from -1 to 8, -1 to 8. The problem with the interval notation is that it doesn't necessarily tell you which one's range and which one's domain. You have to label them. Whereas inequality notation, you put the x in the middle, you know that's the domain. You put f of x, or you could put y, then you know that's the range. Okay, so that's one advantage of the inequality notation, is you put the letter that you're talking about in the middle, then you don't really even have to label which is which. But if you use interval notation, you better label it, because otherwise they both look the same. You don't know which is which. Okay. How's that? A lot of stuff for the, but again, this is all more language-based stuff rather than calculation-based stuff. When we get into 8, that's when we'll do more of the calculations, and we'll apply this stuff. Let's see, where are we? Here we are. Let's clear that out. And then let's take a look at a couple more examples. And then we're almost done for the night anyway. Here we go. We'll jump to it. Okay, so this one, if we want the domain, where do we start? At -4, because that's where the graph starts. Right. So we put our line there. And we keep going until we hit the end, which is right here. So again, I just draw a line. So we could say our domain goes from where? Like -4 to 1. And they're both included because they're both solid dots, so I'll go this way. What kind of notation is that?
Inequality.
Interval.
Oh.
This is interval. Okay. Inequality would be -4 less than or equal to x,
Right.
less than or equal to 1. Okay, so two different ways to write it. And they'll just,
So are they going to interchange them?
They
like
will.
that?
you know, math teachers are tricky. That's how we make our money.
Drive your students crazy.
Make you have to take our classes over and over again. Okay. It's all a plan. It's all a plan. Go with Violet. We haven't used Violet. So then when we come to the range, what do we do? Go to the bottom, good. So that's here, which is actually y equals 0. And then we go to the top, which is there. Let's see if I can draw that right, about there. And again, so the range is between here. So 0 to 3, interval notation. Or I go 0 less than or equal to y less than or equal to 3. So far, so good. Now these next ones are the same, so this makes it a little, we won't actually draw the boxes, but notice how is this a little different? This open circle, what does that say about 4?
Be more than or less than.
Means it's not included.
It's not included, so it doesn't have the equal to part, so x is bigger than -4, but smaller than +1. Okay, so notice it's really sort of the same except without the equal part. They're not, because the endpoints are not included. Those cost extra or something, I don't know. So when we write the interval notation, it still looks like it's going from -4 to 1, but the way we indicate that it's open circles is we put these parentheses. Okay. And I'll give you an example of where this actually gets used so that hopefully it'll make a little bit more sense. So how about the range? The range again is going to be the same values except they're open-ended. So it's still 0 to 3, but we've got parentheses instead of brackets. And we go from 0, y is in the middle, here's 3. It's less than, but not equal to. Okay, they're very similar, but that's hitting you on the difference between an open circle and a closed circle. And the last one, again, very similar to everything else that's going on, but what do we have here?
Bracket.
We got a bracket on that side, it's closed, so there's a -4, but when we get to the other end, which is +1, parentheses. Okay, and again, we got -4 less than or equal to x, and this one is just less than 1. Same thing with the range. Range starts at 0, goes to 3, 0 is included, 3 is not, and so we write that as 0 less than or equal to y less than 3. Okay.
What's the purpose in writing it 2 different ways?
You mean between interval and inequality? Because they can. I don't know. It's a yeah. A lot of times there's 3 different ways to say it. So, but why don't we just stick with one, especially in the beginning? It's true, but it gets used 2 different ways, and sometimes it depends on your major that you're going into, whether they use inequality or intervals. So you'll see them both, and so we expose you to you both. And yeah, we could get by with just one, but I don't know, variety other than that. Okay. Feeling good? Feeling confident? Shall we take a look at one that most people who think they understand throws them off? Okay, so this is the one that used to be on the final. Again, they changed things a little bit, but there was one like, so if you've got this down, great, and I'm going to see if this throws you off a little bit, and if it does, that's okay. Oops. And we don't really have, we won't talk about the practical. I'll let you read about practical domain and range. I'll give you one example about practical range and domain. But let's look at this one. This is the one, the graph at the bottom. Okay, because we've done, the table's kind of boring. It's just listing the numbers. So we'll do this, and let's use our lines because maybe we won't make a mistake like most people do on this one. So when we're looking at domain, where does this thing start? -1. Coming from the left, here's the first point. So I'll indicate that with a line, kind of making my box. And I keep going until I hit the end, which is right here. You agree with that? It's an open circle, but it looks like it happens at 3. So I draw my box to include that. So how would I write my domain? What do I do on the left side? Bracket. On the right side? Excellent. You got that down. -1 less than or equal to x, 3, is just less than. All right, now this range is where it usually gets people, but if you get in this habit of drawing these lines, it might not throw you. So where does it start? I'll stick with green. From the bottom. Always go to the bottom. -5. And where do you think most students will stop?
3,
At the dot.
4.
But it goes higher than that, right? Don't stop at this is kind of a, but you think, oh, they put a dot, that must be where I stop. No, you go to the top. The top is here. So the range goes all the way to the top. And it goes to 4, not to 3. So that dot, we went past it. Now, my question to you is, how do we write the range, though? We start at where? -5. We go all the way up to 4. Do I put a bracket or a parentheses on the left side? It's hard to say, but it's, yeah, it was an open circle there. Now what about the 4? Why? You don't agree. Bracket. So what? Why would it be a bracket, or why would it be a parentheses?
Well, it doesn't start there, so it didn't have a closed.
Doesn't have a closed one, but it also doesn't have an open one, does it? What about this point here on the graph? Is that part of the graph? But they don't put a dot there, right? All of these are dots. What they've done is it's just a drawing thing that when it is there, it's an endpoint, they'll make it big, and they either open or close. But when it's in between here, we just, so the rule sort of is, if there's not an open circle, we assume it's a closed circle. Okay, so what the 4 is, we're going to go there. Okay, and it's not because this could have been open and the 4 would still be closed, because it's, again, so somewhere along there is no open or closed, so we assume closed. Okay, so it's -5 less than or equal to y less, oh sorry, just less than, sorry, my words, I wrote it correctly, but I said it incorrectly. -5 less than y less than or equal to 4. Okay. And that's interval notation and inequality notation, right? So the first two that I do here and here, this is interval. Notation. Because in the homework, the online homework, they'll ask you both, and you just, sometimes you get them right, but if you put the wrong one in the, put it in the wrong slot, then it doesn't get it to you. And then these two over here, these are inequality. Okay. And we go through it. But again, just think of the box. You don't necessarily need to draw it, but just, use your pen to put the endpoints. And it's always from the lowest to the highest for the range. It's always from the furthest left to the furthest right for the domain. When I use, if you do it on paper, sometimes I would turn when doing the range, I just turn it around, and then I'm still looking left to right because it kind of connects it. It's just harder to do with the computer screen, but sometimes you can do it. Okay, so left to right, bottom to top, and you're good to go. I've got a verbal one I'll give you on the practical domain. How many of you guys are low on gas tonight? And I mean your cars, not you. Maybe, yeah, I think we're all kind of low on gas. But the car, so you're going to stop off, maybe put some gas in your car tonight, right? That's an input. Can you put as much as you want? The pump will let you. Well, actually, it'll stop. What's the limiting factor on how much you could put in your car?
However much your
How much your tank will hold, right? If you got I used to have one that had a tank in the trunk that could hold 50 gallons. I think it was a drug runner's car or something. But yeah, I could go like 2 months without refilling because it was a diesel too. So if you have a big tank, you can put a lot. smaller tank, you can only put so much. So if you have a math problem with it, your practical domain is, while yes, you could stand there and pump gas all night long and let it just flow, the amount that you can put in your tank is dependent upon the size of your tank. Okay, so your domain is now limited by the size of the tank. Your range, oftentimes in that kind of a problem, is how much are you going to spend for the gas. And again, that's also sort of limited by the size of the tank, because you can only put in maybe 20 gallons. So you take 20 times the price of the gas, and that gives you your range. Okay. And also, in a lot of those situations, you can't put negative gallons in. I guess, you siphon it out, but you don't put negative. So you're oftentimes in the real world situation, your domain starts at 0 and has some limiting factor, not mathematically, but you can only put so much in, right? And otherwise it spills out. And then your range is the calculation that might be involved, and so how much do you have to pay for the gas that you put in there? There's a calculation. You multiply the number of gallons times the cost per gallon, and that gives you your range. And again, your range is going to go from $0, because if your tank is full, you put nothing in. If it's empty and you put in your 20 gallons, it's 20 times the cost, and there's your range. Okay, but there's limits on them. So when it talks about practical domain and range, it's not talking really about mathematics. It's talking about the real world. What's the limiting factors on my inputs, which will then also limit my outputs. Okay. So that's a whole section in 4, but it kind of tends to throw people that word practical domain. What does that mean? It just means what's the real world situation. And I got, real world gives me limits. I only got so much gas I can put in there. Sometimes it's your dollar. You got $5 in your pocket. You might have an empty tank, but you can only put $5 worth, which when I was going to school, that'd get me a whole week's worth of gas. Now it gets me maybe I'm not sure I can even get home on $5 of gas anymore, right? It's not even a full gallon. Well, no, it's a gallon and, it's not 2 gallons anyway, yeah. Gallon and a half, which depends on what on my motorcycle, it could get me home. But, because I live 33 miles away. Not to make you all feel sorry for me, right? No, I like where I live. So it's all freeway miles, so it's all fun. But when I'm in my car, it doesn't get as good gas mileage. It gets about half, and I need about 2 gallons to get me home. So, yeah. So there's the limiting factors, and we'll look at some problems maybe a little bit on Wednesday, and then we'll spill into 8, because 8 kind of takes all these concepts together, and we start looking at some formulas. And then what I will have for you is a practice test, so that you can start working on it over the weekend to kind of review, and then we got a whole week to go over it, answer questions, and we have a whole week to come back to some of these questions. And if you're understanding, we don't have to go over it. Again, you kind of see, so that's what I try to get everything covered at least the first time, and then we come back with a review test and we take our time going through those. And so anything you didn't get, we'll pick up. Anything you already got, we'll try not to bore you too much. But we'll keep working through it. And the goal is, if you're ready a little bit early, that's fine. I would rather you be ready early than later, right? So, any questions? What's the word of the day? And what does abracadabra mean? Make the disease disappear. So that is cool. Thank you, guys. I'll give you all, how many points of extra credit should we get for that? I mean, I know 2 of you looked it up, but 15. How much is a homework worth?
30 points.
30 points. 30 is a full homework. You think 15 is, okay, so if you, I don't know how I'll keep track of it, but if you're here today, now I got to do something.
I figured.
I'll just give everybody 15 extra credit points because I had fun. I found out what abracadabra means, so that is worth it. That's worth it to me. So y'all got half of an assignment there, so we'll put it in. And span, that was a good one. That's, yeah.
Extra
Span.
15 for you.
Yeah. Good. Good night.
Yeah, it was. I was gonna say, first off, I subscribe to YouTube.